Hi everyone, I am Vijin JS, Assistant Professor, Immanuel Research JJ College of Engineering, Natala. Introduction to Mechatronics. Mechatronics is a synthetic integration of mechanical engineering, electronics, control theory, and computer science into the design and manufacturing of intelligent products and processes. Rather than treating each discipline separately, mechatronic design consider then together from early stage producing systems that are concept renewably and stored. Mechanism system, structure, motion and mechanics, electronics, section, actuations and drive circuit, system, control system, feedback, decision making, computers, software, real-time process and logic. The modular approach to mechatronics. 1. Sensor. 2. Signal condition. 3. Controller. 4. Actor. Sensor. Acquire the physical data. Simplify, filter and convert. Microprocess. PLC execute. Actor control. Convert control signal into mechanical action. Sensor, sensors and translator. Sensor, a device that direct response to physical consider their heat, light, pressure and motion and produce a signal that represent information about the system is. Transducer, a device that convert energy from to another. Example, physical quality into a electrical signal. Every sensor is essential translator. Generalized measurement chain. Physical quantity to sensor translation to signal condition to display and controller. Static characteristics of sensor. Accuracy, sensitivity, resolution, drift, precision, linearity, accuracy, range and sand. Accuracy, closeness of the measured value to the true value. Sensitivity, ratio of change in output to change in input. Resolution, smallest detectable change into the measured quantity. Drift, slow change in output with no change in input over time. Provision, repeatability of readings under unchanged condition. Linearity, degree to which output follows a straight line input relation. High transparency, difference into output for increasing with decreasing input. Range, minimum and maximum value the sensor can measure. Dynamic characteristics of sensor. Dynamic characters describe how a sensor responds to input that change with time to critical when measuring past or transitive physical event. 1. Response time. 2. Time content. 3. Rise time. 4. Selecting time. 5. Bandwidth. 6. Frequency response. Response time. Time taken to reach a specified percentage of the final study value after step input. Time constants. Time from a first order sensor to reach 63.2% of this final value, rise time, time to go to from 10 to 90 percentage of the final steady rate value. Step 4. Selecting time, time for output selected within a specified error bandwidth range of frequency, then sensor can measure with acceptable friendly. 6. Frequency response. Variation of sensor output manufactured to and space with the input frequency. Resistance transistor. Resistance transistor convert a physical quantity into change of electrical resistance, typically measured using bridge or driver quantity. Potentiometer, strain gauge, RTO, thermistor. Wiper positions various resistance, linear angular displacement, resistance change with mechanical strain, force, torque and load self. Metal resistance rise with temperature, precision temperature sensing. Thermistor, semiconductor resistance falls sharply with heat. Temperature over heat protection. Capacity transistor work on the principle sigma A divided A. Physical input change plate area A. Separation D or dielectrical constant sigma alerting capacity. Working modes variable area, variable distance, variable dielectric. Characteristics high density, no contact loading, low power consumption. Application displacement level, humidity and pressure sensing. Limitation sensitivity to strain capacity and environmental humidity temperature. Inductive translator convert to disability into a change self or mutual induction by moving ferromagnetic core within a coil arrangement. LVDT, RVDT, eddy current sensor. LVDT, linear variable differential transformer. Their coils as moving core given a AC output linearly proportional to displacement to higher accuracy frictionless. RVDT, rotary variable differential transfer, some principle adapted to sense angular displacement. Eddy to current sensor, high frequency coil introduce eddy current in nearby conductive target used for non-contact porosity and thickness sensing. Resonant transducer, a resonant transducer conduct to measured into a change in the natural frequency a physical or electrical element, the frequency set into output signal. How it works? The variable element, wire, beam, cylinder, or crystal is driven at its natural frequency changes into the measured tension, pressure, density. Shift and stiffness or mass of the element shifting to the output in cumulative digital frequency, digital and highly stable. Advantage and application. Excellent long-term stability, repeatability. Frequency output is noise, indoors and easy to digest. Used in vibrating wire pressure level sensor. Used in photos resonance process and force sensor. Optical sensor overview. Photo detector, vision system, laser sensor, Fire optic sensor, non-fiber optic sensor, photodetector, photodiodes, phototransistor, photoresistors, and photoavailability cell. Vision system, cameras plus image processing for inspection and guidance. Laser sensor, triangulation and time of flight distance, position sensing. Fiber optic sensor, light guide through a optical fiber, instant types. Non-fiber optic sensor, direct free space, photoelectric and infrared sensor. Photodetector, photodiode, phototransistor, photoresistors, photovoltaic cell, photodiode, reversed biased junction current proportional to light sensitivity. Photodetector, photodiode plus transistor gain for higher output current, high sensitivity. Photoresistors, resistance coils, illumination increase, low cost. Photovoltaic cell generate its own voltage from incident light, no bias need, self power. Vision types systems, image audition, pre-processing, segmentation, feature extraction, interpretation. Typical component, camera, lens, frame, grammar, image processing software. Applications, automated inspection and detection, robotic guidance and bin picking, object recognition, sorting and measurement, barcode by character reading. Laser sensor. Laser sensor is a cone-grounded collimated light beam to measure distance, position, velocity, or surface profile with a high precision. Transmission laser spot in protected onto a target, a position to sensitive data views the pawn from a offset angle. A target distance change the spot image position shift. Geometry gives distance. Time of flight. The laser pulse is illuminated towards the target and sensor measure the time taken from reflection to return. Distance. Speed of light into time. Thank you.